Now we're going to talk about where we're going to apply this geometric mean. Okay, but before we get there, let's talk about this theorem A3, and I'll elaborate on this with sketchpad examples. Okay, theorem A3 states that the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangle and to each other. Now that's a lot, so let's tear that apart. Let's first off recall what an altitude is. Altitude is a segment drawn from a vertex perpendicular to the opposite side. Okay? When you look at a right triangle, if I were to draw the altitude from A perpendicularly to the opposite side, CB, it's already the side. Okay? When I'm looking at the altitude drawn from B to the opposite side, it's already that side. Okay? But when I draw the altitude from the right angle to the hypotenuse, you're going to see it's going to form two new triangles. So let's start talking about that right over here now. Okay, so here's the altitude as defined. The altitude here is BD. Okay, the altitude from the right angle to the hypotenuse is BD. Okay, now the claim is this. Okay, the claim is that that actually forms two new triangles, as we can see here, the green one and the yellow one. Okay, so what they're saying here is that the yellow triangle is similar to the all-inclusive ABC triangle. The green triangle is similar to the all-inclusive ABC triangle, and the green and the yellow are similar to each other. So let's take this apart, okay? First off, I want to look at this claim. Is triangle ABC, the all-inclusive, similar to ABD, okay? ABD is the yellow. So is the yellow similar to the all-inclusive? Well, first off, they both have right angles, okay? They both have right angles, then all we need to do is pair off another pair of angles that are congruent, okay? Well, ABC and ABD both have angle A here. So certainly angle A is another angle that is similar to both, okay? So then we can clearly say that triangle ABC is similar to the yellow triangle. Now we have to watch as to how we name these. So if I'm talking about triangle ABC, then A and A match up, so I'm going to start off with angle A. But ABC, the all-inclusive angle, the right angle is at B, okay? In the yellow triangle, the right angle is at D. So when I match up the angle B, I'm going to match it up with angle D, okay? So therefore, I'm coming up with ABC is similar to ABD, okay? And that's by the double A, or if you want to call it triple A. So that means side AB must be, when compared to AD, right here, must be in the same proportion as BC compared to BD and AC compared to AB. And so I've set those up, those proportions, and we see that they are consistent, and they remain consistent even as I change the dimensions of the triangle here, okay? So regardless of how I look at it, okay, the yellow triangle, the ADB triangle, is similar to the triangle ABC. Now, let's continue on with this. And now I want to show that the green triangle is similar to the all-inclusive ABC. So the all-inclusive ABC, okay, when I look at the all-inclusive and the triangle, the green triangle, then of course we note that they both have this angle here at C. So, and then they both have right triangles. So if I'm going to rename it ABC, then the matchup is C, of course, with C, but the matchup of the right angles is B and D. So if I say ABC, then I'd have to say it's similar to BDC. Okay, so ABC is similar to BDC. And then of course, what I'm going to say is let's take a look at their sides and look at their ratios. Okay, so if I compare side AB to BD, I must make the comparison of side BC with DC and the comparison of side AC with BC. And if I compare them, as I can see, okay, then we have that consistent ratio, okay, and regardless of how I alter the dimensions of that, that consistent ratio remains fixed here, okay? So here you can see that that is clearly the case, that the green triangle is, in this case now, in a 1 to 2 ratio with the all-inclusive triangle, okay? And we're going to hold off and then come back and talk about the rest of this in another video.